Tonight's video lesson is about valence electrons. This is video lesson 2.3 for the Forensic Science unit of our Advanced Chemistry course. My objectives for you tonight are that you'll be able to explain how the valence electrons are a pattern of the periodic table, and that you'll be able to explain the importance of valence electrons in determining chemical behavior. Before we get into valence electrons, let's quickly review what an electron configuration is. An electron configuration is a way to write out all the electrons for a given element based on the energy level, the sublevel, and the orbitals. The further you are from the nucleus of the atom, the higher the energy level. So valence electrons, these are the electrons that are responsible for all chemical behavior for a given element. And they're the electrons that are found at the highest energy level. Generally, valence electrons are going to be found in the S or P sublevels. We're not going to concern ourselves with the transition metals because they don't really follow the rules here. But if we take, for example, here, if we take, for example, boron, okay, and boron has 5 electrons. If I were to write out our electron configuration, it would look like this. And what we can get from this electron configuration here is we can get what our highest energy level is. And the highest energy level is going to be this 2s2, 2p1. The 2 out front indicates our highest energy levels. So from this electron configuration, we can say that we have 3 valence electrons. We get 2 from 2s2, and we get 1 from 2p1. Now let's say we were to look at neon, okay? So neon has 10 electrons. Its electron configuration is 1s2, 2s2, 2p6. Now our highest energy level in this case is still going to be energy level 2, but now we have 8 valence electrons. There's a pattern that exists for valence electrons that's found on the periodic table. To give you a little shorthand on this, is that the entire periodic table is organized into periods and groups. And the period is equal to the highest energy level for that given element. And then groups identify how many electrons are in that energy level. Let's begin with periods here. So the first period of the periodic table is going to be energy level 1 for its valence energy level. Row 2 would be valence energy level 2, or period 2. Row 3, or period 3, all the valence electrons are going to be found in energy level 3. Then we have 4, 5, 6, and 7. So that's one way that you can check to make sure that A, you're writing your electron configurations correctly, that if they're supposed to be found in a specific period or row, it should end with that energy level. The other important thing is this will give you a hint of what your highest energy level is going to be to help you determine what the valence electrons are. The other pattern that exists for the periodic table is that all the elements are pretty much organized into families or groups, and these are our columns of the periodic table. And so on the periodic table here we have column 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A, where this pattern works. And what this means is that all elements in family or group 1A will have one valence electron. When you write out the electron configuration for hydrogen, its electron configuration is 1s1. Okay? If you do the same for beryllium, its electron configuration is 1s2, 2s2, 2 valence electrons, because energy levels 2 is the highest energy level. The same goes for 3A, 4A, 5A, 6A, 7A, and 8A. The transition metals do not follow this rule though. So if the element's found in there, which I won't give you on a test or a quiz, you're not going to be able to use that to identify how many valence electrons it has. The last part of your video note guide for tonight is to watch a quick YouTube video about the alkali metals. And I want you to watch that video and tell me why you think all those elements behave similarly to each other. The web address is on your note guide, and that's all I have for tonight, so have a wonderful evening.